Hello, sixth graders. I'm going to walk through with you 3.1, Estimating with Decimals, just to help refresh the concepts of the lessons today for you. Feel free to pause to help you go at a slower rate as we move through this PowerPoint, or feel free to rewind as well. If you need to go back and you need to look at it again, please do so. This is for you to help you out with anything that you may need about estimating with decimals. If after this refresher you're still unsure and you're not clear about what to do with estimating with decimals, please come see me in the morning and I'll be more than happy to help you, walk through with you some more examples and explain anything else that you may be having troubles with. All right, estimating with decimals. Just a reminder that by the end of this lesson, we want to be able to estimate decimals by finding the sums, the difference, the products, and the quotients. Our one main vocab word in estimating with decimals is called compatible numbers. We're going to use compatible numbers to help solve the math problems today with decimals. Compatible numbers are numbers that are close to the given numbers, so the numbers that they are given us in the example, that can make estimation or mental calculation a lot easier for us. We'll look at different ways we can find compatible numbers to help us better answer the question based on what math operation it is asking us to complete. Remember that as we start estimating and finding compatible numbers, we're rounding. And when we want to round to the nearest integer, we're going to look at the digit in the tens place. If it is greater than or equal to 5, then we round to the next integer. We round up. If it is less than 5, then we keep that same integer. So let's walk through example 1. So we're going to estimate using sums and difference by adding and subtracting. Our directions say to estimate by rounding to the nearest integer. So we have 4.5 plus 8.9. When we have decimals, our biggest thing when we add or subtract is that we line up the decimals and all the place values. So if we set up the problem, it would look something like this: 4.5 plus 8.9. And when we estimate now, we're going to look at the tens place. If we focus on the 4.5, we notice that the 5 is in the tens place, and because it's a 5 or greater, we can go ahead and we can round 4.5 up to 5. Our other digit, 8.9, there is a 9 in the tens place, which means that the 8 now can round up to 9, and then we can go ahead and do our addition. So 5 plus 9 gives us 14. So 4.5 plus 8 and 9/10 gives us 14. Here's another one to help us estimate, but this time now we're going to be looking at a little subtraction, finding the difference. So 28.3 minus 11.7. So first things, we have to set up our problem, line up the decimals and the place values, and now we can look at each individual number and decide if we're going to round it down or up, right? So 28.3, we're either going to round it to 28 or to 29, and we're going to look at the number in the tens place to determine that. So 0.3 is less than 5, so we're going to round 28.3 to 28. 11.7, we can either round to 11 or up to 12. 0.7, the 7 there is greater than 5, so we're going to round that up to 12. And then we can go ahead and do our math. So 28 minus 12 gives us 16. All right, let's do another practice one. Here I notice I have a positive plus a negative, so we're going to have to review our rules again on what we do when we have different signs. First thing first, line up our decimals. And let's look at the numbers that are in the tens place. 57.2, that 2 is not enough to round it up, so that's just going to stay 57. And then we have a negative 23.7. We can either round it to negative 23 or up to negative 24, which in this case the 7 is greater than 5, so we're going to round that to negative 24, and make sure you take the negative sign with it. But now we see that we're taking a positive number plus a negative number. Just because there's a plus sign doesn't automatically mean we have to add them. If we remember from last chapter, our rules say that if the signs are different, we are going to find the difference. So we have to subtract them. So 57 minus 24 is 33. And we know it's going to be a positive 33 because the bigger number, 57, is positive there. So our estimate is 33. All right, we're going to skip ahead a little bit. You can kind of look and see how they set their problem up, they rounded, and then you can go ahead and do the math. Okay? Feel free to try these on your own. Pause it. Take a look, test yourself a little bit, quiz yourself, see how you do by estimating. All right, now we're going to look at compatible numbers when multiplying and dividing. We have a little guidelines to help us remember. So when we're going to multiply with estimating with decimals, we're going to round the numbers to the nearest non-zero integer or to numbers that we can easily multiply. Now we don't want to round to 0 because anything times 0 we know is just 0. So we want to make sure that we are aware of that as we round. When we divide, we want to round numbers so that they divide without leaving a remainder. So we're going to have to use our math facts to figure out what numbers are compatible with another so that it goes in there evenly. Okay, now we're going to estimate products and quotients, multiplying and dividing, with decimals, and we're going to use compatible numbers. So 45.99 times 2.31. Let's take a look here. We still want to look at the tens place a little bit, especially with multiplication. That's okay with doing that. 45.99 would round to 5, right? Round to the nearest multiple of 10 here, it says. We can round this all up to 50. So 45.99, when we round here, we either want to go to 40 or to 50, and this is closer to 50 here. It's more than halfway there. If we take a look at the 2.31, we notice here that 3 isn't enough to round it, so we can keep that as a 2. Now, why is 50 times 2 good numbers, compatible numbers to multiply it by? Well, because we can do that pretty easily. 50 times 2 is 100. So 45.99 times 2.3 gives us about 100. Let's look at a division problem. 51.33 divided by a negative 7.98. As we look here and we take a peek and figure out what can we divide by, dividing by is tricky because we have to find those compatible numbers. You want two numbers that when you divide it by, we get a whole number as an answer. If we look here, 51.33, we can round that to 51. And then negative 7.98, we could round that to 8. However, 51 divided by 8, is that going to give us a whole number? Unfortunately, it is not. So we're going to have to take that 51.33 and round it either down or up a little bit so that we can get a number that is divisible by 8. I look at the number we're dividing by, which is a negative 7.98. You probably want to round that to the nearest whole number, either to negative 7 or negative 8. In this case, it's negative 7.98, so I would round up to negative 8. But then I would go back to the first number, the number the divisor there, 51.33, and 51.33 there, we want to change that number so that 8 can go into it. So if we look around for 51.33, we can round down a little bit at 48. So 48 then divided by a negative 8 would give us a negative 6. Would it be okay if I rounded 51 up to 56, right? Does negative 8 go into 56? That would be okay as well. I would accept that and do 56 divided by a negative 8, which would give us a negative 7. Negative 6, negative 7 are very close to each other. Those would be good estimates. All right, why don't you go ahead and you try one here. 39.62 times 4.99. Well, where can we round it? Feel free to pause. Okay. 39.6, we can round up to 40. We're going to the nearest multiple of 10. Times 5, there we can go to the nearest whole number for 4.99, which gives us then 200. Here's another negative, or dividing with a negative. Make sure our rules say positive divide by negative. If we have one of each, we know it's going to be negative. Then we can look at our division, 19.42 and negative 4.88. Now the negative 4.88, we can round that to negative 5. And then look at the 19.42 and figure out, okay, what can negative 5 go into evenly that's close to 19? And we can say 20, right? We can know 5 can go into 20. So 20 divided by negative 5 is a negative 4. All right, how do we use this in real life? Where will I ever have to estimate with decimals? Well, anytime you go out to eat, you are going shopping, whether it's clothes or food, do you have enough money with you to buy the items that you would like? So here, Kara spent $58.80 on 4.8 pounds of lobster. Use estimation to check whether it is reasonable to spend $12 per pound on lobster. So is it a good deal? Well, let's take a look. We are going to divide these, right? So we can find how much per pound. It was 4.8 pounds of lobster, so we're going to divide. So 58.8 is 60. We'll round this up to 5 there. That 4.8 should be. And now we can take 60 divided by 5, which gives us about 12. So yeah, we can say that, according to Kara's calculation, $12 per pound for lobster is a reasonable answer. Clem spent $18.43 on 11.7 pounds of apples. Check whether it is reasonable to spend about $4 per pound on apples. Okay, so now we have 18 here, 18.43 to be more specific. Round to the nearest multiple of 10, which would be 20. Then we have here 11.7, so we kind of want to round it around so that it can go into 20, which will give us 2. So it's probably not reasonable. You're probably not getting the best deal if you're spending $4. $2 would probably be a really good deal. All right, hopefully this helped you out. If you'd like to take the lesson quiz here, go ahead and pause it and quiz yourself. And then I will show you the assignment to remind you what you need to have finished for this lesson. If you still have any questions, come please see me in the morning. Thank you very much.